Hello everyone, this is teacher Julia and here is the lesson number 2. Our topic for today is linear inequalities in one variable and representing inequalities on a number line. Let me start with vocabulary first. Here you can see the list of conceptions I would like you to know and understand in the end of this lesson. So let's start. Variable, value, solution, substitute, positive infinity and negative infinity. So variable. The lesson number 1, probably you remember we have started to talk about inequality conception. The first example shows the simple comparison of two numbers. 0 is greater than -2 or -2 is less than 0. Another 3 examples are also inequalities, but they contains numbers v, a and x. What are these? Probably you remember example about the speed on highway. Can you remember that the speed on highway should be no more than 65 kilometers per hour? It can be 64 or maximum 65, but not 66. And another example was about age, when you should be no younger than 13 years old to go, for example, to the cinema. You can be 14, 15 and older, but no younger. Minimum, you have to be 13 years old person. X plus 1 is less than 7 is also an example of inequality. All of these 3 examples contains numbers which we call variables, numbers we don't know yet. VAX, variables. Linear inequality in one variable is an inequality with variable raised to the power of 1. And let's see what does it mean. What is this definition does mean? For example, 15a is greater than 10. This is a linear inequality because of the variable a is raised to the power of 1, not second, not third power of 1. That's why this inequality is linear. And you can see also this inequality contains just only one variable a. This inequality also contains one variable y, and it's also linear because of y has a power of 1. This one is also x is less than or equal to 12. Let's talk about this example. If you see inequalities like this, and you can see x on the top, it's a fractional inequalities. X on the top of fractional line. You can rewrite this inequality like 1/3 multiplied by x is greater than or equal to 13. This and this are the same. These two inequalities are the same. X on the top. So actually this is number 1/3. It's a fraction. But please be careful. This example, this is not the same as this. This is not a fraction. This is number 2, integer divided by x. X is below of the fractional line. So this is not the same 2/1 multiplied by x. No, please be careful. If x on the top, this is the linear inequality. But if you divide by x, x is underlined. So this is not linear inequality. This one is an example of not linear inequality in one variable because it contains 2 variables, y and x. we are talking about linear inequalities in one variable. Should be only one variable. And this example is not linear inequality because of it has just one variable, but it's raised to the power of 2. It's not linear. Please be careful with that one. As we just said, inequalities can contain variables. What does it mean to solve a variable? That's mean to find the solution or find the number. What variable is? So a solution of an inequality is a number which, when substituted for the variable, makes the inequality a true statement. Let's consider what does it mean. Solution, that's mean to find the value of variable. What number is variable? The variable cannot be just any number. Only number, or normally for inequalities, numbers, set of numbers. And these numbers make the inequality a true statement. Let's see some examples. Just a moment, please. So, possible solutions for an inequality. For example, very simple inequality, x is less than 30. Please, let's talk about integers, whole numbers. It's easier right now to find the solutions. For this inequality, all of these blue numbers, excuse me please, all of these numbers, they are solutions for this inequality. All of these numbers make this statement inequality true. Let's see, substitute x with number 29. 29 is less than 30, right? Right, this is the solution. 28 is also less than 30. This is the solution for this inequality. And 0 and -1 and -2 and so on until negative or negative infinity. Negative million, -5 billion is also solution for this inequality because of negative billion is also less than 30. This sign, that's mean negative infinity. These are actually, I would say, these are very small numbers. Negative billions, millions, they are really small numbers. Number line, as you know already, is going forever both sides, left and right. All the numbers going to the left of 0 are negative numbers, and all the numbers going to the right of 0 are positive numbers. So there's a negative part, 0, -1, -2, -3, -4, and so on, until negative million, -1, -2, and so on, negative billion. So this is, we can count negative numbers forever. Another example, y is greater than 16. Again, we are talking about integers only right now, about whole numbers. The solutions for this inequality are numbers 17, 18, 19, so on, until positive infinity. As you can see, all of these numbers are solutions because of all of them make this inequality true. 17 is greater than 16. Yes, it's greater. Is 18 greater than 16? Yes, it's greater. And also 21 and 100 and 110 and 1000 and whatever. All of them are greater than 16. And this one, positive infinity, these are really big numbers. 1 million or 5 billion billions, they are bigger than 16, right? the 1 million or billion also makes this inequality true. So the solution for this inequality, as you can see, all normal inequalities has many solutions. Let's see this example. B is greater than or equal to -5. The difference between previous two examples and this example is equal to. You see, it's not just greater and equal to. So B can be equal to -5. You see, -5 is the solution for this inequality. And other numbers should be greater than B. What numbers are these? -6 is less than, right? It's not a solution for this inequality. -5 is the solution because B can be equal to -5. Next number, -4 is greater than -5. -3, -2, -1, even 0 is greater than 5. 1, 2, 100, 200, and whatever, 1 million. All of these numbers are greater than -5. All of these numbers, blue numbers, they just satisfy this condition. B is greater than -5. Positive infinity, this sign shows you a really big numbers. As I said already, on the number line, they are most right numbers, positive numbers, because we can count. There is no final number. We can count numbers forever. All inequalities can be represented on number line. As we said already, all numbers we can put on the number lines, like 0 as the beginning, I would say, beginning of counting. This is the start point. So most right numbers are positive, and left of 0 numbers are negative numbers. For this example, x is less than 6. How to represent this inequality on number line? So first, we have to find number 6 on the number line. Where is it? That's here. Number 6. Following our inequality, number 6 should be less than 6. So all of these shaded blue numbers, all of them, 5, 4, 3, so on, -1, -2, negative infinity, all of them less than 6. These blue numbers, they are solutions, all of them solutions for this inequality. For this example, x is greater than or equal to 2. So let's find number 2 on number line. That's here. Can you see number 2 and the circle above the number 2 is shaded, is closed, colored with green, filling green. Because of number 2 is also solution for this inequality. Can you see x can be equal to 2 or greater than 2? So all of these numbers shaded green, all of them, 3, 4, 5, 6, 7, and until positive infinity, all of them are solutions for this inequality, and all of them greater than number 2. For this, this is little more complicated inequality. It contains 2 parts. Okay, let's say the first part, x should be greater or equal than number 2, but x, the another part is x is less than 6, cannot be more than number 6. So let's find points 2 and 6 on the number line. Here's number 2, here's number 6. So all numbers greater than number 2 are going to the right of number 2. These numbers 3, 4, 5, x is all of these numbers are greater than 2. Can you see 2 is closed circle because x can be equal to number 2. Number 2 is also a solution for this inequality, this part of inequality. Until 6, we can x cannot be equal 7 because 7 is greater than 6, so 7 is not included. So this is the range from 2 included 2 until 6. This is the solution, these numbers are solutions for this inequality, shaded red. So let's summarize our lesson. So for inequalities containing sign, strict sign greater than or sign less than, we should use open circle for showing on the number line. Number 2, this means x is not equal to number 2. Number 2 is not included. It's not a solution for these two inequalities. But for these two inequalities, if x is greater than or equal to or less than or equal to, we use closed circle, which shows you that number 2 is the solution for these two inequalities because of x can be equal to number 2. We show that like closed circle on number line. That's all for the lesson number 2. Please go to the lesson number 3. It's placed in supplementary mathematics. So see you on the lesson number 3. Bye bye.